In this lesson, we will be solving logarithmic equations, and you do so by rewriting it as an exponential equation. First step is to isolate the logarithm. You may need to condense logarithms if necessary using the properties of logs. Rewrite it as exponential, then solve for the variable. First example, solve algebraically for all values of x. As you can see, x plus 4 is the base, right? Since the log is already isolated, we must go around the world. X plus 4 squared equals 17x minus 4. So there we have it. We've written it as an exponential equation, and we must FOIL. After you FOIL, you basically solve the quadratic. Subtract 17x, add 4 to both sides. And two numbers that multiply that give me 20 that add to negative 9 are x minus 4, x minus 5. And therefore the solution set is 4 and 5. You must always do a check step. Right? You take 4, you plug it back in. You take 5, you plug it back in. You want to check if you're taking the log of a negative or 0 number. That does not happen here, so 4 and 5 are both acceptable answers. Okay, number 5, we go around the world. We have x to the negative second power equals 1/4. We rewrite x to the negative second power as a positive exponent, which means it's reciprocated, so it's 1 over x squared equals 1/4. Cross multiply to solve, and x squared equals 4. And the answer is 2. Okay, so you do number 5. We go around the world again. X to the negative second power equals 9. So you rewrite it as a positive exponent, so it's 1 over x squared equals 9 over 1. We cross multiply. 9x squared equals 1. We divide both sides by 9. And you take the square root of both sides. X equals 1/3. Number 6, same thing. You go around the world, right? We want to rewrite the logarithm as an exponential. And we have 9 to the 3/2 power equals x. Now normally, well, not normally, but this is how you would solve this algebraically. You have square root of 9 cubed. And square root of 9 is 3. 3 cubed is 27. X equals 27. Now on the calculator, you could achieve the same result by plugging in 9 to the 3/2 power and just getting 27 that way. So remember, when you take the fractional exponent of a number, you must put the fraction in parentheses. Very important. Number 6. And this is the you do number 6. Same thing. Go around the world. 8 to the 2/3 equals x plus 1, and the 8 to the 2/3 power is 4. As you can see, if we use the calculator, 8 to the 2/3 gives us 4. You must put 2/3 in parentheses. Subtract 1 from both sides. The answer is 3. Number 7, you must condense. We have log base b of 36 minus log base 2. We condense. We end up with log base b of 36 over 2 equals log base b of x. Now, just like if you have, say, 5 to the x power equals 5 squared, you can just cancel the bases, the common bases, and just equate the exponents. You can also cancel when you have the same log and the base on either side of the equation. So you cancel those out, we end up with 36 over 2 equals x, and 36 over 2 is 18. You do number 7. As you can see, log base x of 4 plus log base x of 9. We use the product property, so it's 4 times 9. It's 36. We go around the world. X squared equals 36. Square root of both sides, and x equals 6. Number 8. Again, go around the world. 2 to the negative third power equals x plus 8. 1/8 equals x plus 8. We subtract 8 from both sides, and we end up having to find a common denominator, and 1/8 minus 8 is really 1/8 minus 64/8. And our solution is negative 63/8. Now we could have also done this on the calculator. 1/8 minus 8 is negative 7.875. Use the math fraction function to change this decimal to the equivalent fraction. You do number 8, going around the world, 4 to the negative second power equals x plus 1. We end up with negative 15/16, and again, we could have done this on the calculator by using the fraction button. Number 9, probably one of the most important problems of this lesson. First thing you must do is condense using the product property. So we have x plus 4 times x minus 2. We must FOIL. We get x squared plus 2x minus 8. Next thing you do is rewrite this as an exponential. So we go around the world, and 3 cubed equals x squared plus 2x minus 8. 3 cubed is 27, so we solve the quadratic, minus 27 on both sides. X squared plus 2x minus 35, so we must factor, and we end up with x plus 7 times x minus 5. And our solution set is negative 7, 5. Now, the check step is very important because when you plug negative 7 back in, you end up with taking the log of a negative number. As you can see, you cannot do that, so negative 7 is rejected. It's an extraneous root, and the only acceptable root is 5. And the last one, similarly, we're going to use the quotient property. And when you use the quotient property, you end up with x squared minus 4 over x plus 2. We want to factor the difference of squares. The x plus 2's cancel. So now we go around the world, and 3 squared equals x minus 2. Adding 2 to both sides, x equals 11. And there's the lesson. Best of luck to you.